All right, just as a review, we started looking at multi-step equations yesterday. We talked about the order to solve, that we work our order of operations backwards. So we undo addition and subtraction first, and then we undo any multiplication or division. We also looked at a couple of exceptions to the rule. If one side of the equation is a fraction, then we have to take care of that denominator first before we can do our other steps. Or if we have multiple sets of parentheses, we have to distribute first and then combine like terms to make that happen. We looked at a few examples of just naming what the first step would be. Then we talked about what are some possible types of solutions that we could get when we are solving equations. We said we could get one solution, and that's where we have the variable equals some number. We could get no solution. That's where the variable disappears and the two numbers that are left don't equal each other. Or we could get infinitely many solutions, which a lot of you are familiar with IMS. And this is where the variable cancels out and the two numbers are equal to each other. So then we started looking at some examples yesterday. In problem number 5 there, we had to combine like terms first before we could solve and find out that x equaled 1. In problem number 6, we had several steps. We even wrote them out. The first step was to distribute the 4. Then we added 12 to both sides. Then we divided both sides by 8 to get m equals -5. Then I had you do number 7 on your own, and I showed it both ways, but most of you, I think, did it method number 1, where you distributed the -5. One of the key things I saw in that one, though, was a lot of people forgot about their negatives. Make sure we're paying attention to the signs. A negative times a negative is always going to give us a positive, and a negative times a positive is always going to give us a negative. So we have to be careful with those values. All right, we've got some more examples to get through today before you get your homework, so we're going to work some more together here. So number 8, 7 equals 4 plus the quantity n divided by 3. This one has a fraction, but the entire side is not a fraction. So in this one, I'm going to write the steps off to the side here. The first step here would be to subtract 4 from both sides. So if I subtract 4 from 4 and 4 from 7, I'm left with 3 equals n divided by 3. Now I can undo my division, and I undo my division by multiplying, so the second step would be to multiply both sides by 3. So I'm going to multiply by 3 here, which is going to cancel out my denominator, multiply by 3 here. So what is 3 times 3? 9. So I can say 9 equals n, or I can flip that around without changing the meaning and say n equals 9. And then we talked about our solution sets yesterday, because that's what you'll see on the answer key of the odds that I'll post for you. This is how they would write their answer key. They would put the 9 in brackets to say that that is the solution set of that problem. Okay, the next page we have a few more examples here. Number 9, 7 equals negative 8 plus x, all divided by negative 4. This time, the entire side is a fraction, so that's one of those exceptions. The first step here would be to multiply both sides by 4, or by negative 4. Because we have to clear that fraction before we can do any of our other steps. So I'm going to multiply this by negative 4 by negative 4. This side will cancel out. So what is negative 4 times positive 7? Negative 4 times positive 7. Anyone? Negative 28 equals negative 8 plus x. So now what is the next step? Once I've cleared that, what would I need to do next in this problem to find out what x equals? What would be my next step? Yeah, so my next step is add 8 to both sides. It's a negative 8, bless you. So I'm going to add 8 because I'm going to do the opposite of what I see to get negative 20 equals x, or we would just say x equals negative 20. And again, on the answer key, you would see the set of brackets with the 20 inside the brackets. All right, number 10 is our other exception. We can't go into our rules of undoing until we distribute and combine like terms. So the first step is going to be distribute and combine like terms. So we have to do that first here before we can do anything else. So I have to distribute the negative 8 to this parenthesis and the negative 7 to this parenthesis. So I have negative 8 times 1, which is negative 8. What is negative 8 times positive 4x? Negative 32x. And then what is negative 7 times positive 4? Negative 28. And negative 7 times negative 6x. No. Close. Negative 7 times negative 6 would be positive, so plus 42x equals negative 66. Now, as part of that first step, though, we have some like terms. We have negative 32x and positive 42x that we need to combine. So negative 32 plus 42 would get me a positive 10x. And then we have negative 8 plus negative 28 that we need to combine, which will give us negative 36 plus 10x equals negative 66. Now I can get into actually solving once I've done all those steps. I have to simplify the problem so I know what I'm looking at before I can get into the other steps. So I've distributed, I've combined like terms. So now step 2 here is add 36 to both sides. And the reason I'm adding it, I have that negative sign in front of the 36. I always want to do opposite of what's in the problem. So I'm going to add 36 to both sides. So I have 10x equals, what's negative 66 plus 36? Negative 30. And then I need to divide both sides by 10. Because I want to get that away from the x. I want the x to be the last thing standing. So I would have x equals negative 3. Or again, you might just see the negative 3 in the brackets as to show that that's the solution. All right, so 11, we're going to follow those same steps. Obviously, the numbers may be different than what we just did in number 10, but we're going to follow those same steps here because we have the multiple parentheses. So I'm going to distribute. I have to distribute the negative 6 through, and I have to distribute the positive 2. One of the biggest mistakes that gets made when working with the distributive property is we forget to multiply the second set of numbers. Most people get the first ones because they're next to each other, but a lot of people forget to distribute it through and do the second. So here we would have negative 56 equals negative 6 times b would give me negative 6b. Negative 6 times positive 7 would give me a negative 42. 2 times negative 7 would give me a negative 14. And 2 times 3b would give me plus 6b. So we have to combine some like terms. We have a negative 6b and a positive 6b. So if I combine those, what's negative 6 plus 6? Should add up to 0. Negative and positive of a same number should add up to 0. And then we have negative 42 and negative 14 that we have to combine. Because they are both negative, we're going to add them. So negative 42 plus negative 14 would give us negative 56. So negative 56 equals 0b minus 56. Do we write 0b in our problem? When we get to the 0, because what is anything times 0? 0. So really this would be negative 56 equals negative 56. What did we say was the solution when the variable disappears and the two numbers left equal each other? Yeah, this is your IMS. This is your infinitely many solutions. This is your IMS because it doesn't matter what the value of b is. Negative 56 is always going to equal negative 56. So I can put any value in for b and make this equation work. Okay, number 12, we got one more in that same set. We've got to distribute. I've got to distribute the negative 5 to the first set of parentheses and the positive 5 to the second set of parentheses. So I have negative 1 equals negative 5b minus 35 plus 5b minus 10. So again, I have a negative 5b and a positive 5b. What do those add up to? Yeah, I have 0, so negative 1 equals. And then I have a negative 35 and a negative 10. So those add up to negative 45. So does negative 1 equal negative 45? Are those two equal? No, those are not equal. So what did we say happens when the variable disappears and what's left is not equal? No solution.